NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we solve floor bracket equations of the form left bracket x, right bracket plus left bracket, y right bracket equals k, with k an integer. We will follow a clear, case-based algorithm and visualize example solutions. First, the key definition. The floor of x equals n if and only if n is less than or equal to x, and x is less than n plus 1, where n is an integer. Step 1. Understand the structure. We have one equation with two unknowns, so typically there are infinitely many solutions. We will split into two cases based on k equals 0 or k not equal to 0. Step 2. Case 1, k equals 0. Use the zero-sum property. A plus b equals 0 implies a equals negative b. Here, that gives floor x equals negative floor y. Examples. If floor x equals 1, then x is between 1 inclusive and 2 exclusive, and floor y must be negative 1, so y is between negative 1 inclusive and 0 exclusive. If floor x equals 2, then floor y equals negative 2, and y lies between negative 2 and negative 1. Step 3. Case 2, k not equal to 0. Isolate floor x. Floor x equals k minus floor y. Picking any integer value for floor, y produces a matching integer for floor x, and thus an interval for x. Sample pairs. If floor y equals negative 2, then floor x equals k plus 2, which means x is between k plus 2 and k plus 3. If floor y equals 0, then floor x equals k, so x is between k and k plus 1. Now, an example. We take k equals 5 and find a specific solution by choosing a convenient integer for floor y. Let floor y equal 1, so y is between 1 and 2. Then floor x equals 5 minus 1, which is 4. Therefore, x is between 4 and 5. Let us visualize these intervals on a number line to make the solution feel concrete. General solution. Let n be any integer and set floor y equal to n. Then floor x equals k minus n. That means y is between n and n plus 1, and x is between k minus n and k minus n plus 1. This describes all solutions. Summary. The equation bracket x plus bracket y equals k always has infinitely many solutions. If k equals 0, then the floors are opposites. If k is not 0, isolate to get floor x equals k minus floor y, and pick any integer value for the floor of y. Next topic, solving single variable floor equations, such as floor ax plus b equals c. We will solve a floor function equation by following the exact step order shown on screen. First, we display the word example. Then we show the problem in bold orange. Open bracket x close bracket plus open bracket y close bracket equals 23. Now step 1, rewrite the equation to solve for open bracket x close bracket. We will apply the isolating the variable rule. Show the step title. Then show the rewrite from open bracket x plus open bracket y equals 23 to open bracket x equals 23 minus open bracket y. Step 2. Identify the infinite solutions and present a specific example. We apply the floor function definition rule. Show the step title. State that the equation has infinitely many solutions. Now, a quick challenge. Pick an integer for floor of y and predict the interval for x. We will choose floor of y equals negative 2, which means y is in the interval negative 2 to negative 1. Compute floor of x equals 23 minus negative 2 equals 25, which means x is in the interval 25 to 26. Step 3. Provide a second example. Show the step title. Show a short tip that any integer value for floor of y will work. Choose floor of y equals 5, then y is in 5 to 6. Floor of x is 23 minus 5 equals 18, so x is in 18 to 19. Now we present the final answer as a set description and celebrate. The solution set is all real pairs x, and y such that floor of x plus floor of y equals 23. To wrap up, we summarize the key ideas. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.